You slept 9 hours last night. No alarm, no obligation. Just the pure, uninterrupted sleep that every health article, every doctor, every well-meaning person in your life has been telling you to get more of. And you woke up feeling worse than you did on Tuesday when you slept 6. The heaviness behind the eyes, the reluctance to sit up, the coffee that normally clears your head in 15 minutes taking 45. The joints stiff, the mind slow, the entire morning blurred by a fog that has no business showing up after the longest rest of your week. You know this feeling because it is consistent, so consistent that you have learned to expect it. Long sleep feels worse than moderate sleep, and nothing you have ever read, no article, no physician, no guideline, has given you a satisfying explanation for why. Today that explanation exists, and it changes everything you thought you knew about sleep. THEU-QRVE, a study published in Nature this year followed more than 500,000 adults and measured aging differently than it has ever been measured before. Not as a single number, not as one biological age. Instead, researchers tracked independent aging clocks. One for the brain, one for the liver, one for the lungs, one for the immune system, one for cardiovascular tissue. Each organ aging on its own timeline, measured through imaging data, blood proteins, and metabolic markers. When they plotted sleep duration against those clocks, the data drew a curve shaped like the letter U. Both extremes accelerated the aging. Sleeping fewer than 6 hours pushed every organ's biological age above its chronological age. But sleeping more than the individual optimal did exactly the same thing. The organs of people who slept too long aged just as fast as the organs of people who slept too little. The bottom of the U. The duration associated with the youngest biological age across every measured clock was narrower than any public health guideline has ever recommended. The conventional recommendation does not sit at the bottom of that curve. It sits above it, on the slope where additional hours correlate with additional biological aging. 9 of the full set of clocks showed the same statistically significant U shape. The pattern was systemic. Imaging data, protein data, and metabolic data all drew the same curve. When 3 independent measurement technologies replicate the same finding, the result stops being suggestive and becomes structural. This is biology, not artifact. But a curve is only a shape. It shows where the damage accumulates. It does not reveal the mechanism underneath. CL/S, the grogginess offers the first clue. Sleep cycles run approximately 90 minutes: light non-REM sleep, deep slow wave sleep, REM, and back. A person sleeping 7 hours completes 4 to 5 complete cycles and tends to wake naturally during the final light stage, the phase the body prepares for waking. A person sleeping 9 hours adds another full cycle and frequently wakes mid-cycle, deep inside slow wave sleep. The result is severe sleep inertia. The clinical term for the fog, the thickness, the impaired reaction time that can persist 20 to 40 minutes after waking from the wrong sleep phase. The grogginess is not a sign you needed more rest. It is a phase error. You woke at the wrong point in the cycle, and the extra sleep created the extra cycle that put you there. There is a second mechanism, less established but consistent with the neuropharmacology. Neurotransmitter systems that drive waking alertness. Norepinephrine, serotonin, histamine, orexin are largely quiet during sleep. Extended sleep means extended silence in these systems. And prolonged silence may trigger compensatory receptor upregulation, the neurons increasing their sensitivity to compensate for the prolonged absence of signal. When the neurotransmitters surge at waking, recalibrated receptors produce a sluggish, oversensitized response instead of the crisp activation of a properly rested system. It is pharmacologically identical to caffeine tolerance. Chronic caffeine use upregulates adenosine receptors, and temporarily removing caffeine produces exaggerated drowsiness. Not from fatigue, but from receptor miscalibration. Extended sleep may produce the equivalent of a withdrawal effect from wakefulness itself. 2 mechanisms, neither definitively isolated as the primary driver, both predicting the same experience: the extra hours feel worse, and both producing the same behavioral trap. The oversleeper interprets the grogginess as evidence of insufficient rest and sleeps longer the following night, deepening the problem. The sensation of needing more sleep is the body misreading a problem caused by too much sleep. The signal and the remedy point in opposite directions. THERANCLAINDISWASASTIUM, to understand what is physically happening inside your brain during the hours beyond that optimal window, you need to understand a plumbing system that most people have never heard of. In 2013, Researchers demonstrated that the interstitial space between neurons expands by approximately 60% during sleep compared to waking. This expansion is driven by glial support cells, cells surrounding every neuron, physically shrinking to open fluid channels that remain sealed during the day. Cerebrospinal fluid floods these channels, flowing along the outside of blood vessels through what was subsequently named the glymphatic system. That fluid carries waste, amyloid beta, the protein fragment that accumulates in Alzheimer's disease. Tau, the structural protein whose tangles correlate with dementia severity. The accumulated metabolic exhaust of approximately 86 billion neurons firing across 100 trillion synaptic connections for 16 consecutive hours. Estimates suggest the brain produces around 7 grams of waste protein every day that must be cleared overnight to prevent accumulation. The driving force is entirely mechanical. Each heartbeat generates a pressure wave that propels a small bolus of fresh CSF deeper into brain tissue. Venous drainage on the opposite side pulls spent fluid outward. The CSF percolates through the narrow gaps between neurons. Channels measured in micrometers, forces measured in millimeters of mercury, sweeping waste toward drainage pathways at the base of the skull. The physics is identical to groundwater flowing through porous rock. Pressure head on one side, a drain on the other, permeable tissue in between. The system is elegant in its simplicity and brutal in its limitation. It cleans by flowing, and it stops cleaning when the flow stops accomplishing net transfer. WTHE Girardi and Turan showed the concentration gradient between fresh CSF and waste-laden interstitial fluid is steepest at the onset of sleep. The first hours of clearance are the most productive because the differential is large, the flow is strong, and the waste removal rate is at its maximum. As clearance proceeds through the night, the gradient diminishes. The CSF entering the channels and the interstitial fluid surrounding the neurons converge toward the same waste concentration. The driving force weakens hour by hour. Net transport approaches zero. The system does not shut off. The heart continues beating. The CSF continues circulating. But circulation without a concentration gradient is movement without purpose. The fluid enters carrying the same waste concentration as the fluid already there. It picks up nothing. It exits unchanged. The mechanical infrastructure is running. The clearance function has completed. Think of a washing machine. The first rinse cycle removes most of the dirt because the concentration difference between clean incoming water and the soil in the fabric is enormous. By the fourth cycle, the water going in and the water draining out carry nearly identical concentrations. Running a fifth cycle does not make the clothes cleaner. The driving force has been spent. The machine is circulating clean water through clean fabric, consuming energy, consuming time, producing wear, while accomplishing nothing. The gradient has a timer. The exact moment it reaches practical zero in living human brain tissue during extended sleep has not been directly measured, but the fluid dynamics are unambiguous and the population data is consistent. The U-curve turns upward at durations that align with the predicted equilibrium window, and existing animal data shows that extended anesthesia beyond the normal sleep duration does not increase amyloid clearance proportionally. Diminishing returns, exactly as the physics predicts. The extended clit dementia comes the dimension the washing machine analogy does not reach. Imagine opening every window in a smoky room. The first 10 minutes of cross ventilation clear most of the particulates because the concentration differential is enormous. After an hour, the concentrations have nearly equalized, but the smoke particles that remain after equilibrium are not simply present. They are actively depositing residue on surfaces, walls, furniture, fabric. Extended contact time between residual pollutants and surfaces is itself a damage mechanism entirely separate from the initial exposure. The hours beyond the optimal sleep window may not be failing to clear waste. They may be actively extending contact time between residual waste proteins and living neural tissue, and those proteins cause damage when they remain in sustained proximity. Amyloid beta in sustained contact with synaptic terminals promotes oligomerization, the aggregation of individual protein fragments into larger toxic clusters. Tau in sustained contact with neuronal microtubules promotes hyperphosphorylation, the chemical modification that causes tau to detach from the structural scaffolding it normally stabilizes and instead form the pathological tangles associated with dementia. The hours beyond gradient equilibrium are hours during which residual waste is actively converting from harmless individual fragments into pathological aggregates. The system has not simply stopped cleaning, it has started accumulating damage at an accelerating rate. 23 Argyan COKS, 23 mechanisms. The glymphatic gradient explains what is happening in the brain, but it cannot explain the immune system's ascending slope on the U curve. The immune system does not rely on CSF flow. Something else is aging the organs outside the skull. The Nature paper, led by Junha Wen at Columbia University, revealed that the U-shaped curve is not one curve. It is 23 overlapping curves, each organ drawing its own U with a slightly different base and a different slope. The brain's proteomic aging clock showed the strongest U shape of all, with an aggregate optimal window emerging across all measured clocks that sits below the conventional guideline and inside a narrower range than any public health recommendation has ever specified. The brain's optimal sits at 7.7 hours for men and 7.8 for women, a sex difference that aligns with known differences in glymphatic fluid flow, where estrogen modulates the expression of aquaporin, 4 channels in the cells lining the perivascular pathways. The immune system tells a different story. Extended horizontal immobility during long sleep allows inflammatory cytokines to accumulate in tissue compartments that would normally be cleared by the gentle mechanical agitation of waking movement. The lymphatic system, which runs immune surveillance, clears senescent cells, and identifies precancerous mutations, has no intrinsic pump. It depends on muscular contraction to drive fluid through one-way valves. Horizontal stillness is the enemy of lymphatic flow. Beyond the optimal window, the morning cortisol surge that should reactivate immune patrol fires into a body still horizontal and still asleep. The patrol that should have resumed at 6 does not resume until the extended sleeper finally rises. Inflammatory markers, interleukin-6C reactive protein, tumor necrosis factor alpha, rise incrementally with each additional hour of immobility beyond the optimal point. The aging clock accelerates because the morning reactivation the biology was expecting was delayed by hours the body spent resting past the point where rest was doing anything. The liver responded to a third mechanism entirely. Not how long you sleep, but whether you sleep at the same time each night. Variable wake times desynchronize the liver's internal clock from the master timing signal in the suprachiasmatic nucleus. The SCN recalibrates within a day when the wake time shifts. The liver clock takes 2 to 3 days. Its metabolic rhythms run on enzymatic cycles with longer half-lives than the SCN's neural oscillation. Sleeping a standard duration on weekdays and extending on weekends produces a weekly desynchronization cycle that forces the liver clock to perpetually chase a timing signal that moves before it can arrive. Cardiovascular tissue ages through a fourth mechanism, the autonomic transition stress of waking. A consistent wake time produces a consistent transition from parasympathetic relaxation to sympathetic activation, a transition the vascular endothelium adapts to and anticipates. An irregular wake time produces irregular transitions. Unpredictable mechanical stress on coronary arterial walls. Unpredictable stress accelerates endothelial aging. Adults who combine long weekend sleep with irregular schedules showed the steepest acceleration on their cardiovascular clocks. 2 damage pathways acting on the same tissue simultaneously. THRL optimal wendio sleep latency. The time between lying down and actually falling asleep averages 12 to 20 minutes in healthy adults over 50. Nighttime awakenings accumulate 20 to 40 minutes in adults over 60. A person who goes to bed at 10 and sets the alarm for 6 has created an 8-hour opportunity window. Subtract 15 minutes of average latency and 30 minutes of fragmentation, and the actual sleep duration inside that window is 7 hours and 15 minutes. Well inside the 6.4 to 7.8 hour optimal window the data revealed. That person sits near the bottom of the U while believing they are not sleeping enough. Every sleep guideline ever published tells you how long to stay in bed. The U curve measures how long you actually sleep. Those two numbers diverge by 30 minutes in a healthy 30-year-old. They diverge by an hour or more in a healthy 65-year-old. The guideline and the biology are measuring different things, and the gap between them widens with age. The irony runs deep. The 65-year-old who lies awake frustrated, convinced they are failing to get adequate sleep, is often sleeping inside the optimal window. The 30-year-old who falls asleep in 12 minutes and sleeps efficiently through the night is frequently sleeping above it. The recommendation was accidentally protective for the population it frustrates most, older adults. and potentially harmful for the population it fits most comfortably. Teach experiment. I ran this myself. Lights out at 10:15. Alarm at 5:45. 7.5 hours of opportunity. The sleep tracker registered 6 hours and 52 minutes of actual sleep, 14 minutes of latency, 24 minutes of accumulated wakefulness across 3 brief arousals, 6 hours and 52 minutes. Inside the optimal window, below the gradient exhaustion threshold, above the minimum clearance requirement. The mornings were clear. The fog was absent. Same schedule every day of the week, including weekends. The suprachiasmatic nucleus received the same calibration signal every morning. The liver clock stabilized by midweek. The immune clock stabilized by Thursday. Saturday morning, 5:45, no obligation to rise. The body rose anyway. The grogginess that used to define Saturday mornings was gone because the Saturday wake time matched the Tuesday wake time, and the liver clock that would have spent Monday recalibrating never had to recalibrate at all. By day 10, the alarm was redundant. The SCN woke me 3 minutes before it. The biology and the schedule had synchronized. Look your morning shower. The first 5 minutes under the water removed the accumulated film of the night, dead skin cells, sebum, bacterial residue. The concentration differential is high. The transfer is rapid. By minute 10, you are standing under warm water flowing over clean skin. The cleaning finished 5 minutes ago. The warmth feels productive. The perception of benefit has decoupled from the physics of benefit. The 20th minute is not cleaner than the 5th, but stepping out is difficult because warmth is indistinguishable from cleaning. The shower does not announce when it stops being productive. Neither does sleep. The 9th hour of sleep is the 20th minute of the shower. The glymphatic gradient equilibrated hours ago. The immune patrol is stalled in lymphatic channels, waiting for vertical posture and muscular movement. The organ clocks are drifting upward on curves the body cannot feel from inside the horizontal comfort of a bed that stopped restoring some time ago. You feel warm, horizontal, and free of obligation. The biology interpreted those signals as recovery continuing. The transition from restoration to stagnation is silent, comfortable, and entirely invisible from inside it. Fixed wake time protects the consistency, sensitive organs, liver, immune system, cardiovascular tissue. Controlled duration protects the gradient, sensitive brain. Vertical posture in the morning protects the immobility, sensitive immune system. 3 variables. Every measured clock. 1 number inherited from a century of labor scheduling. A partition that divided the day into 3 equal parts, that the body never endorsed and the science never validated. The glymphatic system was not discovered until 2012. The U-curve was not drawn until the dataset grew large enough to resolve both slopes simultaneously. 500,000 adults in Oregon, specific aging clocks revealing a window narrower than any guideline had ever recommended. The optimal range is 6.4 to 7.8 hours of actual sleep, not time in bed, not opportunity, sleep, a gradient that exhausts, organ clocks that tick independently, a U-shaped curve that punishes both sides of the error equally. The biology is narrower than the advice, it always was, and the narrowness is not a limitation, it is precision, the inherited target overshot. The alarm is not the enemy. It is the signal that keeps every measured clock synchronized, the gradient finite, and the biology inside the window where the organs stop aging and start restoring. Set it. Keep it every morning, including Saturday.